Hello students, hope you are well. Today I want to discuss on Graham's law of diffusion, relation between rate of diffusion and molecular mass of the gas, kinetic theory of gases, expressions of root mean square velocity and kinetic energy of the gas, characteristics of ideal and real gases. Let's start. What do you mean by diffusion of the gas? The spontaneous distribution of very fine particles like gaseous molecules or atoms in all directions is called diffusion of the gas. For noble gases, fine particles means atoms. Diffusion is a random movement of gaseous particles from a region of high concentration to the region of low concentration. For example, smell of fruits, scent of fresh flowers, smoke from a candle. For above all cases, the gaseous particles move from high concentration area to low concentration area. Graham's law of diffusion. What is the statement? At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to square root of its density. If small r is the rate of diffusion and small d is the density of the gas, then according to this law we can write r is proportional 1 by root over d. Dear students, you know velocity equal to distance by time. Similarly, here rate of diffusion equal to volume of gas diffused by time. R equal to K constant, then root over D. If you consider two gases, gas 1 and gas 2, R1 equal to K by root over D1, R2 equal to K by root over D2. Dividing this by this, then we get R1 by R2 equal to root over D2 by D1. This is equation number 1. Dear students, you also know density equal to mass by volume. Density equal to mass by volume. If mass is molar mass, then it will be molar volume. So density equal to molar mass by molar volume. Dear students, you know at constant temperature and pressure, molar volumes of all gases are same. At constant temperature and pressure, molar volume of oxygen equal to molar volume of nitrogen equal to molar volume of ammonia, and so on. So here at constant temperature and pressure, molar volume of first gas V1 equal to molar volume of second gas V2. From equation D equal to mass by volume for fast gas, we can write D1 equal to M1 by V1 and D2 equal to M2 by V2. Putting these values in equation 1, R1 by R2 equal to root over M2 by M1. This is equation number 2. It is proved that from equation 1 and 2, the rate of diffusion of a gas is inversely proportional to square root of density or molecular mass of that gas. Square both sides of equation 2, then we get R1 square by R2 square equal to root over R1 square by R2 square equal to M2 by M1. So M2 equal to R1 square by R2 square into M1. Putting the values of R1, R2, M1, this is molecular mass of known gas. Then you can calculate the value of M2. This is molecular mass of unknown gas. Dear student, from equation 2, you can find out which gas diffused faster between nitrogen and oxygen, ammonia and hydrogen chloride, chlorine and hydrogen, and so on. Kinetic theory of gases. The theory that explains the behavior of gas molecules is called kinetic theory of gases. To explain the properties of gas molecules, different scientists gave different opinions from their experimental evidence. The ideas which are accepted are known as kinetic theory of gases. Main assumptions or postulates of kinetic theory of gases are: number 1, gases consist of tiny particles, atoms or molecules. Molecules of a gas have same size and shape. Hydrogen gas molecules size and shape for each molecule is the same. The size and shape of hydrogen gas molecules and carbon dioxide gas molecules must be different. Gas molecules are in constant random motion due to the collisions among gas molecules or the collisions on the wall of the container. Collision of gas molecules is perfectly elastic since no loss or no gain of energy during collisions. The particles or gas molecules are so small compared to the distances between them. Large empty spaces are found among the gas molecules. This molecule is very small in size, is very little. The distance between this and this is large. There are many large empty spaces among the gas molecules. So volume of gas molecules is very negligible compared to the total volume of gas container. Vg is very less than Vc. Volume of gas molecules is very less than Vc. This is volume of gas container. The average kinetic energy of gas molecules is directly proportional to absolute temperature. When temperature is increased, the movement of gas molecules increases, or gas molecules move faster. Then kinetic energy of the gas increases. Again, if temperature is decreased, gas molecules move slowly. Then kinetic energy of the gas molecules decreases. Kinetic energy is proportional to absolute temperature. Gas molecules are non-interacting. There is no attraction or repulsion among the gas molecules as they far apart from each other. Gas molecule, this is another gas molecule. No attraction or no repulsion between them. The pressure exerted by the gas is due to the collisions of the gas molecules on the walls of the container. The higher number of the collisions, greater forces applied on the walls of the container produces greater pressure of the gas. The pressure exerted by the gas molecules is due to the collisions of the gas molecules on the walls of the container. The higher number of the collisions, higher forces applied, produces greater pressure of the gas. Pressure P equal to force by area. The force applied by gas molecules on the wall of the container per unit area is pressure of the gas. No effect of gravity on gas molecules. Gas molecules, it can move to this direction, it can move to this direction, move to this direction also. This is Earth's surface. Earth surface. It is not attracted by Earth's surface due to the less density of the gas. Dear students, you know density equal to mass by volume. For gas molecules, mass is very negligible, volume is also very negligible. So gas molecules have a less density, so it is not attracted by Earth. Gas molecules are floating on the surface of the Earth. On the basis of the postulates or assumptions of gas molecules, kinetic gas equation is PV equal to 1/3 mn c square. Here P pressure of the gas, volume of the gas, small m mass of each molecule, capital N total number of gas molecules. C, this is root mean square velocity. Root mean square velocity is used for gaseous substances to explain, to get more accurate result from different calculation.